Welcome to day 4 of the AWS AI Practitioner series. So, if you haven't yet watched our first 3 AI sessions, I recommend starting there. They will give you the solid foundation you need to get the most of from today's discussion. So, in this series, our mission is simple. So, to help you truly understand the concepts behind the AWS Certified AI Practitioner exam, we go beyond memorizing answers, focusing on the why and how. So you gain knowledge you can apply with confidence in both the exam and real world AI projects. So you'll still see exam style questions, but always in the context of the concepts we cover, ensuring you are prepared to think, not just recall. So today's video will be short. The concepts we are covering: AI evaluation metrics for classification and regression models, and Amazon Q. So this can be challenging to grasp, especially those evaluation metrics. So I'll share simple techniques to help you remember them. For a deep mathematical and statistical understanding, so this evaluation metrics mostly caters with those mathematical and statistical background if you have, but which is beyond the scope of any AWS AI certifications. So which will include a resource link if any of you guys are interested. So let's dive in and connect the dots between the concepts, the services, and how they work together to deliver real value. So let's quickly cover 5 key AI evaluation metrics you need to know for the AWS AI Practitioner exam. First is BLUE, stands for Bilingual Evaluation Under Study. So it's actually used to assess the quality of machine translated text against human translations. So next is so whenever in the exam you will see that a blue is the option that you will understand that that is referring to surface level similarity, means it compares the n-gram overlap between generated text and a reference. Next is BART score. It actually measures the semantically similar two text are. So this word is very important, semantically similar, that only BART score can give. Next is ROSH. The full form is Recall Oriented Understudy for Gisting Evaluation. It is designed for evaluating summaries by comparing them to reference summaries. So whenever you see summaries, that means it is going for the Roche. So these all are AI evaluation metrics for anything whenever you need to understand that model is performing well or how it is performing. Next is word error rate or WER. It actually measures transcription accuracy in speech recognition. Mainly it's used for speech recognition only. Finally, this perplexity, not that company, it's the evaluation matrix. It shows how well a language model predicts the next word actually. And lower perplexity means obviously better predictions. So if you master all these, you will be ready for the exam. So now try to just for the exam, whenever you see translation, don't just keep your mind shut that it should be blue. If you see anywhere it is asking for meaning, that means and this semantic similarity, that means it's BART score. If it's summary, text summarization or summary, that is Roche. If it is going for the speech recognition, that is WER or word error rate. If it is for prediction, that is perplexity. Okay. So now, before going to evaluation metrics for classification model, in case you don't know what is classification model, so classification models is actually predicting the category or labels. So in simple words, that which bucket does it belong to, where these models are used. Suppose email spam detection, any email is spam or not, if you want to do any sentiment analysis, those kind of things. So in short, that if you want to identify that which should be the category, then these kind of models are used. And what are the evaluation metrics? One is accuracy, that it actually measures overall correctness of prediction. So when your classes are balanced, that accuracy is the metric by which it is trying to identify your overall correctness of predictions. Means how often am I right overall? If you want to understand in a very simple way, how often am I right? Precision is of all predicted positives, how many are truly positive? It focuses on quality of positive predictions. So in short, when I say yes, how often am I right? That kind of analogy. Recall is the sensitivity also, it is called. So of all actual positives, how many were correctly predicted? It's actually focusing only on all positives. That means of all the real yes cases, how many did I find? That is recall. Another is F1 score, harmonic mean of precision and recall. We are not going to the formulas because that are not relevant for the exam. So it has specific formulas also. In F1 score, it is actually balances both when you need a single score. So if you, in short, F1 score, how well do I balance between precision and recall? That is actually F1 score. And area under the ROC curve, that is AUC ROC, is how well the model separates positive from the negatives across thresholds. Means higher AUC, obviously better discrimination ability. That means in short, how well can I tell a yes from no at any threshold? So these are the points that you need to remember, specifically accuracy, precision, recall. This will come an F1 score. That is, you can understand that balance between precision and recall. And these all are for classification models. So there is another kind of model that is called regression model. Uh, it predicts continuous numerical values. For example, in stock price prediction or sales forecasting. Questions can come in that way, that which kind of model can give the output in only numeric value. Then the answer should be regression models. And whatever this matrix you are seeing, this might not come in, or this will not come in the exam, but it is just for to know the purpose that in regression kind of model or in AI, these things exist, but these are not relevant for this specific exam. So mean absolute error, mean squared error, these are all metric by which through AWS we can understand these models are giving error, and where should I apply and how to correct it. Suppose, for example, uh, if you want to penalize that larger error, okay, then if any model is giving very huge error and you want to penalize it, then the metric by which a system can understand or AWS can understand, that is MSE or mean squared error. And other evaluation techniques are there, median, AE, Hubbard loss. This entire slide that you are seeing, only you need to remember for exam that regression model gives the result in numerical values. Okay, so in short, classification model is which bucket does it belong to, and regression model, that what number should I predict. That is the thing you need to remember. But before those things, that whatever the other metrics I told, that accuracy, precision, recall, F1 score, and BART, blue, rogue, this you need to remember for exam. Okay. Now that is now matrix is over. This is Amazon Q. This is a very simple service that Amazon built, and it's a AI powered assistant, you can say, that is designed where it's a chatbot. You can ask questions, get insight, and task across any AWS services and business data. But there are three kinds of Amazon Q, and question are there, question used to come. So it's very simple to understand. The three types of Amazon queues are Amazon queue business, queue developer, and queue in QuickSight. So if in case you do not you are not familiar with QuickSight, QuickSight is a AWS service which is specifically for data analytics and dashboard to and show those data, and Amazon Q and QuickSight is integrated here. So Amazon Q business, it actually generate answers or question and answers and content from company's internal data, documents, wikis, tickets, etc. So mainly uh, suppose, for example, if anyone asks that what's our latest sales forecast, so instantly it will try to go into your organization sales documents, internal documents, and try to generate a report. So this is a memory hook just we have given. B, that is for business brain and knows your company's knowledge. Amazon Q developer, just think if you need to write code or debug or anything, this kind of thing, which specifically for development activities. For example, you need to generate a Lambda code or fix a cloud formation syntax. So then you should use for Amazon, and then you should use Amazon Q developer. Suppose uh, you want to you have written a Python script, you want to correct it, you are not sure about a specific syntax, you can just put it in the Amazon queue in the chatbot. It can fix that, it can give you the suggestion or where is the error or what you can do. Amazon Q QuickSight, it's completely NLP, this natural language queries for data analytics and dashboard. You can, example is that suppose show me sales by region for last quarter. It will give you a chart. Okay, so to remember, BDQ, B for business, D for developer, Q for quick insights. Okay, so that is Amazon Q. Now going to the questions. A company has built a solution by using generative AI. The solution uses large language models to translate training manuals from English into other languages. The company wants to evaluate the accuracy of the solution by examining the text generated for the manuals. Which model evaluation strategy meets these requirements? First option is Blue, second is RMSE, third is Rouge, and fourth is F1 score. If you remember, here it's I just give you the word translate. You do not need to see anything. It means translate. That means it will be blue. Question 2. Which strategy evaluates the accuracy of a foundation model that is used in image classification task? A, calculate the total cost of resources used by the model. B, measure the model's accuracy against a predefined benchmark data set. C, count the number of layers in the neural network. D, assess the color accuracy of images processed by the model. Whenever we try to evaluate the accuracy, it's always recommended you need to define a benchmark data set, predefined benchmark data set by which you can evaluate the accuracy. That is the only way to understand that model is how much accurate. So the answer should be option B. Question 3. A company is using a pre-trained large language model to build a chatbot for product recommendations. The company needs the LLM outputs to be short and written in specific language. Which solution will align the LLM response quality with the company's expectations? A, adjust the prompt. B, choose an LLM of a different size. C, increase the temperature. D, increase the top K value. See, top K value and temperature, these are kind of distractor here because these are for model performance improvement, for creativeness or better output. But here they are saying that output needs to be short and written in a specific language. So with this, choose a LLM of different site also doesn't make sense. So here best option will be adjust the prompt. That will be the, and any question if it is not written also, try to think two things. One is cost effectiveness Another is operational efficiency. You need less effort. So adjust the prompt will be less effort. Question 4. A company is building a mobile app for users who have a visual impairment. The app must be able to hear what users say and provide voice responses. Which solution will meet these requirements? A. Use a deep learning neural network to perform speech recognition. B. Build ML models to search for patterns in numeric data. C. Use generative AI summarization to generate human-like text. D. Build custom models for image classification and recognition. We haven't covered this concept that is called deep learning. So in this question, if you see, they are asking to build a mobile app for visual impairment. And app must be able to hear what user is saying. That means we need to build up another layer also for hearing. So this is part of deep learning actually. So deep learning in very short, a type of machine learning that uses artificial neural networks with many layers. That is why it's deep, many layers, to automatically learn patterns from large amount of data, like how our brain processes information. It powers things like speech recognition, image classification, language translation, and chatbots. So to understand on the or remember for exam, deep is many layers. Learning is finding patterns. Whenever you are seeing any questions which is talking about, you need to develop multiple things in many layers. Uh, for first is visual things, then hearing things, or you need to find pattern also. Then voice here also it's there. So that is the place where deep learning is a suitable option. So the answer should be option A. A company wants to create a new solution by using AWS Glue. Glue, I covered a little bit that it's an ETL tool, and the where you can transform the data, right? So here the company has minimal programming experience with AWS Glue. So they're asking which AWS service can help company use AWS Glue. So if you think like this, without going to the option, Glue it specifically, then you need some developers kind of people. So they mentioned they do not have people who have programming experience. So, or they have minimal programming experience, they mentioned. So ideally, this should go to a service where where AWS is helping for developers. So all of these comprehend personalized config, this cannot help with anything with developers. So the answer should be Amazon Q developer. Last question for this video. A healthcare company wants to develop a machine learning model to predict the likelihood of a patient developing diabetes based on various health indicators. Which of the following metrics would be the most appropriate for evaluating the model performance? First, okay, we need to select two. Option A, accuracy; B, precision; C, F1 score; D, recall; E, area under ROC curve; AUC, ROC. So if you remember, accuracy, I told that percentage of total predictions that are correct, right? So here they are asking likelihood of a patient developing diabetes based on various health indicators. So accuracy cannot be the thing because it's not predicting the correctness. Precision, of all predicted positives, precision is how many were correct. That all, then precision cannot be the option. F1 score is actually balance between precision and recall. So recall is actually, if you remember, of all the positives, how many were found. So here, if you see, predicting the likelihood of a patient developing diabetes, that means how many they have taken the readings for multiple patients, out of which how many were found for diabetic, how many patients were diabetic. So that means recall can be one option. F1 score cannot be the option because it's a balance between precision and recall. Then we are remained with another option, that is uh, area under ROC curve, which is ability to separate the positive from negative across thresholds. So here also, with the help of recall and AUC ROC, we will be able to evaluate that how many patients are actually diabetic, and with AUC ROC, we will be able to will get the ability to separate the positives. Means positive means here diabetic. So the answer should be recall and AUC ROC. Okay, so that's all for this video. Thank you for joining. Please don't forget to subscribe our channel. Thank you.